This is question 5C from the exam review package. It's a car driving and a truck driving. So this is actually number 4 and 5. Number 4 is the car. And it says the car starts 200 meters west of the town square. So I've taken west to be negative. So west is further down, below 0 is west. This is 0. And then east is above 0. So positive is east and negative is west. And this y-axis for the question is displacement. So I'll say displacement in meters. That's the vertical axis, the y-axis. And so if you're, it says the car starts off 200 meters west of the town square. So that's your y-intercept. Because in this case, the displacement is your y-axis. And what's the x-axis? Good. So this is your time in seconds. And the car is going 15 meters per second. So what part of the graph is the speed of the car? The slope. Very good. Who said that? I don't know. Yeah, the slope. So the car starts down here, 200 meters west of the town square. I made the town square 0, because that's our kind of town square equals 0. So that's right here. And the car starts 200 meters west, and as time goes by, the car is driving towards the town. Does this mean that the car drove past the town and never went through the town? What does it mean? What's this point signify right here?
That when
Time.
they get to the town square, it's been like however many seconds.
Good. So this is the time when the car is at the town. Okay, because the car is driving towards town. But this is just time passing. And that slope is constant. What does that mean about our motion?
It's meters per second.
Yeah, constant velocity, right? Okay, so we get all that. And the equation of the car is going to be d equals 15t. That's my speed, that's the slope. And minus 200 is my y-intercept, which is where I started. So when time is 0, I'm 200 meters west, which is negative 200. So that's how you make an equation of something moving. And then number 5, it tells us about a different vehicle, a truck, that starts 400 meters east of town. So it's positive 400 when it starts, it's up here. So this is the truck. And this is the car. And the car is moving this way and the truck is moving that way. But they're not actually moving in the diagonal direction. They're moving straight towards each other. This is just time passing. Okay. And the truck's going 12 meters per second in which direction?
West.
Good, west. And so we have to make that negative. So it starts off east, but it's traveling west, so the velocity has to be negative. So this is the equation for the truck. Now, the interesting question is, when does the truck and the car pass? Well, you can do it graphically. I just put this graph on Desmos, and I just inserted the 2 equations with y's and x's, because Desmos understands y's and x's. And you can just click on this point and it'll tell you where it is. It's 22.2 and 133. What's the 22, do you think?
Time.
That's the time. And the 133 is my
Distance.
y-axis, which is the distance. This is plus 133, so is that west or east?
East.
East in this case, east of town. You don't have to do that graphically, you can do it mathematically. If you take these 2 equations and you say, when they pass each other, their position, their displacement will be equal, yes? So, the displacement for the car is really this, and the displacement for the truck is really this. So if you make these 2 things equal, you should be able to solve for the time when they are at the same place. And so you put this part of the equation for the car and this part of the equation for the truck, and you make them equal. And then you just solve, you guys know how to do this algebra, you just do the like terms, and you solve for t, and what you'll calculate is that it's 22.2 seconds. Same as what you see on the graph. And then if you want to find out where they are at that time, you can put this 22.2 seconds into either of these equations, and they will both punch out the same displacement because the car and the truck are in the same place. And that's a good way to check if you're right. Because if you got the right time, the displacement for each one should be the same, and you'll find it's 133. Okay, that's it.